First of all, we will require a microcontroller, that is Arduino UNO, which will be required to control the signals according to the conditions given in the code. A breadboard is required to make the connections easier, changeable and organized. A DC power supply to provide power to the fan. One of the major components of the model is the LM35 temperature sensor that will be used to read the outer temperature and send the signal to the Arduino. The 2N222 transistor acts as a switch and controls the fan speed depending upon the signal. The diode is used to protect the Arduino and the other components of the circuit from being damaged by the reverse EMF. Other than this, we will also require a 10 microfarad capacitor, an LCD with I2C, some few LEDs and some resistors of 1 kilo ohm. So this is the circuit which we have made using the Tinkercad. First of all, the connections of the LCD is established with the Arduino. As you can see, the ground and the VCC are connected as it should be. Then we have made the connections of the LEDs. As you can see, we have connected 3 LEDs here which will glow indicating the temperature. Then we have one of the most important components of our circuit, that is the LM35 temperature sensor that will read the temperature and send the analog signal to the Arduino's A0 pin. It is also being powered by the 5V that is supplied by the Arduino. After the input, now talking about the output, the Arduino here gives digital output signal as PWM from the D11 pin and is the combination of the resistors, capacitors, transistors and the diode, which is the main system that is helping us to control the fan speed depending upon the signal that the Arduino is giving. And finally, this is the connection of the DC fan that we have made with the circuit. Now for testing the circuit, this is the code and we are starting the simulation. As you can see, the current temperature is 25 degrees Celsius in the temperature sensor, so the fan speed is 0% as the minimum temperature is set to 30 degrees Celsius. As we have increased the temperature now, you can see the temperature is 49 and the corresponding fan speed is 63%. And as you can see, according to the temperature, the two LEDs are glowing, and as we zoom in, we can see that the motor has gained an RPM and it is rotating. So we can say that all the connections have been done correctly and the circuit is working properly. And after putting this all together, it looks like this. So now we are giving power to the Arduino. As you can see, the current temperature is 38 degrees Celsius and the fan speed is about 25 to 29%. It's rotating. Only one LED is switched on as it depends on the temperature. And now as we bring the incense stick close to the temperature sensor, the temperature will increase. And as you can see, as the temperature is increasing, the fan speed also increases subsequently. It has already reached 50 degrees Celsius and all the LEDs are switched on now as it has reached almost 90%, and
The fan is rotating at about 90% speed. And now as the incense stick is removed, slowly the temperature is decreasing back to the normal temperature, and as a result the fan speed again decreases.